So let's start section 6.7, our applications section. It's titled Models of Exponential Growth and Decay. And I'm projecting here a handout that is posted in Canvas. So I hope it's readable in the video. I'm going to write out the solutions by hand to the word problems that are on this handout. And you should refer to a PDF copy of the handout that is posted in Canvas. So we're going to focus on two kinds of applications called exponential growth and decay. And first of all, exponential growth. Right now we're kind of living in a time where exponential growth is relevant because that's used to describe the spread of many diseases such as the coronavirus. We're not going to look at disease in these problems. We're only going to look at population examples. And we're going to work with functions that can be written in the following form. F of t equals a0 e to the kt. It turns out any exponential function can be written in this form, and we like base e in math because a lot of the kinds of things we end up doing with functions are easier to do with base e. So just notice in this form that there are two constants. There's this a sub 0 or a0, and there's also a k. So for an actual function, we're going to have a value, a numerical value for a0 and a numerical value for k to be able to work with that function. And another observation we want to make, and it's spelled out on the handout, but if we plug in 0, f of 0 is a0 e to the k times 0. So I'm substituting 0 in for t. And what I get is a0 e to the k times 0 will be 0 no matter what k is. E to the 0 is always 1, so I have a to the 0 times 1, or just that a sub 0 or a0. So what we're observing here is that we know there's a meaning for this a0 constant. It's equal to the function value at 0. Or another way to think of that is that 0 comma a sub 0 is the y-intercept on the graph. One other thing about the formula too, just notice that we use t for an input variable here instead of x. And I think that's done because in most applications the input variable will have units of time like years or hours or minutes. And so t helps us remember that that the input variable is a time kind of quantity. Okay, so let's go ahead and start. We're going to work on exercise 1. And so in exercise 1, we're told the population of a growing city is given by the function f of t equals 90,000 e to the 0.08 t, where t is the number of years after 2000, and f of t is a number of people. So I have the function copied here on my handwritten paper, and I just noted on the side here that t stands for years after 2000. So t equals 1 is like 2001, t equals 2, 2002. And the function value, the output, or like the y values that we get here, will be numbers of people, number of people. And maybe just, we don't have to, this isn't part of the problem, but just notice here that the a sub 0 value in this formula is 90,000. And the k value, the k constant, is what that 0.08 is. All right, let's start answering these questions, the different parts of the exercise here. Part A is how many people live in the city in the year 2000? So in part A, we want to find f of t when t is equal to 0, because that corresponds to the year 2000. So f of 0 is 90,000 e to the 0.08 times 0. Now, I kind of just went through this argument a few minutes ago, so once you see it, you won't have to calculate it each time. I know what I'm going to get for f of 0, and you should know too, but I'll go through it one more time here. We have 90,000. That's going to be e to the 0 power, 0.08 times 0 is 0, which is 90,000 times 1, which is 90,000. So there are 90,000 people in the year 2000. And that's the answer to part A. You could have just written it down, right? Because we already talked at the very beginning about how that a sub 0 value is always going to be the function value at t equals 0. So once you learn that fact, you can just write it down. You could have just said, yep, I know that's what 90,000 means. All right, part B. Question is, what is the population in 2019? So we want to find f of t when t is equal to 19, because that corresponds to the year 2019. So we're going to plug in f of 19 is 90,000 e to the 0.08 times 19. And you got to use a calculator for these. There's no way to get through these calculations by hand. 0.08 times 19 is 1.52. So I have 90,000 e to the 1.52. You'll need to know how to take e to a power on your calculator. In fact, you can do all this calculation at once. You don't have to write out steps for this. On my calculator, I have 1.52 on the screen now. My e to the x button, I have to hit the shift key to get through to it. So I go second e to the x. And now I'm just going to go right ahead and multiply my result times 90,000. And I'm going to have to round off, because you'll often get messy decimal answers here. Looks like I have 411,500. 411,500 people. That's the population in 2019. And then part C of the question is, when will the population reach 500,000? So in part C, we actually have to find t when f of t is equal to 500,000. And so I'm going to take my function f of t equals 90,000 e to the 0.08 t and replace f of t with 500,000. equals 90,000 e to the 0.08t, and I have to solve for t. And this is really where exponential equations will come up in applications, where t is in the exponent here. So we need a way to solve for an exponent variable. And so we got to invoke our process from our previous section, right? We're going to isolate the exponential. So I'll start out by dividing both sides by 90,000. I'll get 500,000 over 90,000 equals e to the 0.08t. I can reduce this fraction quite a bit now, so it reduces to 50/9 equals e to the 0.08t. And now, in order to get the variable out of the exponent so we can solve for t, I'm going to take ln of both sides. ln of 50/9 equals ln of e to the 0.08t. Now, ln and e cancel out, basically. So we're going to end up with just that 0.08t out of the exponent. I'm going to write this out because we were writing it out earlier as an application of the third law of exponents. So I can bring the 0.08t out in front times ln of e. But ln of e is always equal to 1. So we're just going to have ln of 50/9 equals 0.08t. And I'm just about ready to solve for t here, right? I have to divide both sides by 0.08. So ln of 50 over 9 divided by 0.08 is my t value. And I got to do that on my calculator. 50 divided by 9. And you need to use your ln button. Mine's right here. And then divide by 0.08. And again, I'm going to have to round off. It looks like I'm getting t is about 21.4. Now that's years, right? But we want to know in what year is the population 500,000. So that's between 21 and 22. So in the year 2021, the population reaches 500,000. So I'm not going to ever try to be tricky with the t values here, but here we do have to translate it into a statement about the year, right, and not just the value of t. Okay, I'm going to try to back out a little bit so I can get the whole thing projected here and leave it up there for a second. So I'm going to stop this video. We'll continue in a part 2 video with more of these word problems.